Hello there, this is Daniele from Toolchefs and welcome to this new video. Today we're going to have a look at how we can apply foot locking to our simulation. I'm going to open the Atoms UI as first thing, and we're going to use two FBXs that I've downloaded from Mixamo. One FBX is for the character and the other one is for the animation. As you know, with Atoms you can export animations and skeleton as well as skin files from your Houdini scenes or a Maya scene. But Atoms also works with external files coming from other sources, like in this case Mixamo. So we can create a new agent type. We're gonna call it Mixamo, and then I'm gonna select the skeleton file, which is this FBX here. I'm gonna use the same FBX for the skin. I'm gonna click save, and if I show the skin, this is basically the character that I've downloaded. If now I hide the skin, we see that this joint here is colored in green, and this is because when Atoms cannot find a pelvis, so a joint that is tagged as pelvis in the skeleton coming from the skeleton file, then it will tag the root joint as the pelvis. Now we're gonna tag both the pelvises and the legs directly here in the Atoms UI. So basically this is how you can properly configure your agent types, even though these files are not originally coming from Atoms. So the first thing that we want to do is we want to sanitize the joint names, because as you see from Mixamo, when you download a file, the joint will contain a namespace. So I'm going to click sanitize joint names. This will remove the namespace. Now we can say that the hips is a pelvis. This is not going to change anything here because of course it was already tagged as a pelvis, but just as again for the sake of completeness we're tagging it as a pelvis as well. Then here we can select the foot root, the first foot root. So we have two legs here, so the first one is going to be right up leg, and then we have the IK, which is the right foot. Also, if you want, you can even select the joints here and right click and say copy joint name and copy paste. Then here the pole vector. The pole vector is a point in the 3D world space, and it has to be in front of the leg. So as you see here, as soon as I selected the root, this value here updated. This is the world position of that joint, the right up leg. So if I draw the joint world position, let me just hide the names for a second. We see here we have minus 6.6, minus 8.8, minus 0.44, and so on. So basically, this is exactly the position of that joint. We want to make sure that this pole vector is actually in front of that joint. So we're gonna move it on the Z. So because again, this is a world space, and maybe set a value like this, like 3. So now we see that the pole vector is there, and the joints are colored, so it means that the leg is properly tagged. Now we want to do the same for the left leg, so left up leg and left foot. Left, if I can spell it, foot, and then left toe base. And again, here we're gonna put 3. So now we have put legs properly tagged, and we can save this. So now we can go in the animation clip event. I'm gonna create a new animation clip. So I'm gonna call it walk. I'm gonna select walk in FBX. So as we see here, now we have the animation being loaded, and here we can assign first of all a direction type. So we're gonna say this is the direction 001, and it's gonna be static. This is because the agent is actually moving along the z-axis, if we see like this. And then we're gonna assign a compatible agent type, which is gonna be Mixamo. I'm gonna save. Now as you see here, it looks like the character has this skeleton has no animation. This is because the Atom is not able to match the joints coming from this agent type with the joints coming from this animation. And this is because here in the agent type, we sanitize the joint names, but we didn't do it the same here. So if we do that and save, now we see that the animation is back. So then we want to set the start and end frame of the animation. I believe the last frame is 29. Here there are a lot of frames in this FBX, but after frame 29 there are the same pose. So we're gonna say 0 to 29. Here we can say the loop blend is 0 because the first and last pose of our loop basically they're the same. Of course, if you have like more frames after frame 29 and the movement of the clip is is continuous, so basically it's not just a static pose, it keeps walking, then you can provide some loop blend for better looping. Okay, so for now, let's just save this one. Actually, for the last thing before we keep going is we can override the pelvis and feet height, and this is because from Mixamo, of course, this animation that Atoms needs for the simulation is not in the Mixamo FBX yet. So basically, when Atoms load this FBX, it is not able to get this information from the FBX. So we can enable this option. We can provide a value for the ground height, which in this case we can leave it safely at 0 because as we see here, this animation is properly made and is above the XZ plane. So we can safely say that the ground height is the XZ plane, so it's the origin basically. So we can say it's 0, we can save, and now this information is is stored inside the Atoms animation. So if I go here and create a new agent group, we can create a grid layout. We're just going to create one agent because what we really care is just we want to debug the foot locking. So we can say animation, we want to apply a clip, and then we're going to also create a directional module, which all the directional modules are used for steering your agents and moving them, moving them around. So we're going to use a follow curve. And then here in the module, we're gonna use the Mixamo character, and then the clip, we're gonna use the walk, like this. And yeah, so let's change the skin like this. Okay, let me just move the agent group a little so that is above the XZ plane. We could use an eye field, but anyways, just for making things a bit quicker now, we're just gonna do like this. So if now I press play, we should see, yeah, the agent is working straight. And there's no foot sliding because the animation Mixamo animations are actually pretty good. So let me just change the FPS of this scene. So we're gonna change it to 30. So if I press play now, yeah, everything looks great. Okay, so let me just quickly create a curve so we can make the agent follow that curve. So we can make a Bezier like this. I'm just gonna make this very sharp turn, which is not gonna make a lot of sense. I mean, it's not gonna make a lot of sense to make an animation like this, but it's just for the sake of this test. So if now I go in the agent group and I go on the follow curve and I select that curve there, and if I press play, we see basically that the feet are actually sliding quite a bit. To fix that, what we can do is to go in the Atoms UI, and we can set the foot down state here directly on the clip. So if you have the foot down coming and being stored directly on the clip, which happens whenever you use our tools, our exporters, then you wouldn't really need to load it here and set here unless the foot down data on the feet is not properly wasn't properly stored by our exporter, in which case you can still go here and modify it. Otherwise, if you don't have it, I mean, sorry, in that case you would press the load from clip and you would see the graphs here, but in this case we don't have them. So you can compute the graphs here directly. We have two modes, velocity and ground height. We're going to use the ground height here. And I like to use that because I can just specify a value which is going to be my ground height. And whenever one of the tips is below the value that we're going to provide here, then Atom is going to assume that the foot is down. So here we see that at this frame, the Y value, the global Y value for the tip is 1.12. So we're going to use here 1.15. And then we're going to say compute. Here now we see this yellow disk appearing. And if we go through the timeline, we see the foot down is actually quite good, except this point here. We see here the foot is down, but it's not actually set us down for that foot. We don't see the yellow circle. So just for these 4 frames, we're gonna select them and move them here. So now we see that the foot down is properly set. Great. So now if I go back to my simulation and I press play, we see that the feet are actually being locked during the simulation. Of course, again, this curve doesn't make a lot of sense, but it was just to show you how you can actually apply the foot locking. If you don't want to, even though you have the graphs here configured, you can still disable the foot locking by using this checkbox here. And if I go back and I press, yes, we see now that the foot lock is again disabled. But anyway, for this case, like, it's good to just keep it on, keep the foot locking on. So if I press play now, we see that the foot locking is back again in action. Cool. So this is all for this video. Thanks for watching.